Golf's a great game, and all of us want to play better. We take lessons and we practice. But have you ever wondered, could there be some bad variables in my equipment that are not helping me? Well, in this series of 16 tips, we're going to explore all the different areas of equipment so that you can evaluate your clubs and your game and decide, is it me or is it my equipment? Our job in this series is to take every bad variable out of your equipment that does not help you. There are 5 very important putter fitting variables, and each one of those variables is a factor in controlling the distance of a putt and or the direction of a putt. So one we're going to talk about today is the first variable that we really need to fit, and that's putter length. And putter length works like this. When we go into a store, a pro shop, wherever we go to buy our putters, there's going to be a rack of putters in the store, and we end up finding men's putters to be either 35 inches or 34 inches on the rack. Ladies' putters are basically 33 inches on the rack. Well, the average man's going to fit into about 33 or 33 and a half on a putter, and as low as 32 or maybe even a little lower than that. The average lady is going to fit into 30, 31, somewhere in that area. So why do we want to worry about the standards of 33 for women and 34 and 35 for men when we know right now we might have a little bit of a problem? We don't want to go in and just buy it off the rack and it may or may not fit us. We want it to be sure that it fits us, and in all likelihood we're probably going to have to go shorter. So here's how we fit putter length. And I got a mirror on the ground right here, and this is a great device. There's other ways to do this, but the mirror is great. It helps me get my eyes over the ball and I can see where I'm at in trying to get into the proper posture position. That's how we fit length. So I also have a shoulder alignment line on it, which is just another nice thing to know if your shoulders are parallel and lined up with the way you're setting up. So when I want to set up, I go in here and get my knees slightly bent, arms are hanging below my shoulders, I put them on the putter and I get ready to putt. There are my eyes right there. Remember, you want your eyes over the ball to slightly behind the ball. As much as an inch is probably okay. But you don't want your eyes over the ball in this direction out here. The reason we want our eyes over the ball is very simple. If our eyes are way back here, say 5 or 6, 7 inches back from the ball, when we look out at the hole, there's an angle created looking from our eyes to the hole back to the ball, and we got to calculate that when we're putting. Why not get our eyes over the ball so we can see the line and not have to calculate some angle? So eyes over the ball in the proper posture position, and we check the putter out, and you can see that this putter is much too long for me. One of the things I like to do is use an adjustable length putter, and it's in a lot of stores and a lot of people have them, and you don't have to have this. You can just simply, when you check it out, put a little piece of tape or mark whatever when you find out that you need to cut your putter down. This is set and it's adjustable, as you can see. This we're going to set here at 34 inches for me. It's not my correct length, so I'm going to get in here and check this all out, and the same thing's going to happen. Eyes are over the ball, the putter is much too long for me. So I happen to know I'm 32 and a half, so I get down to 32 and a half and set the putter, and now I get over this. Eyes are right over the ball, knees slightly flexed, arms are hanging right under my shoulders, and now this putter fits me perfectly. And I can stroke it properly, I get good distance and directional control. So remember that the proper length is 50% distance control of the putt and 50% directional control of the putt. Very important. Don't overlook standard length, and just don't go up and buy a putter right off the rack and walk out the door. You need to get it fit to the proper length. There are 5 very important putter fitting variables. Each one of those variables controls the distance and or direction of the putt. So what we're going to do here is look at loft. Very important fitting variable. Loft controls the distance a putt will go. Very critical. Let's take a look at my high-speed camera and see what happens with 4 degrees of loft on a putter, which is the correct loft. We generally want 3 to 4.5 degrees of loft. This high-speed camera goes up to 1/40,000th of a second shutter speed and 2,000 frames per second. So you can see now that we have the impact with the ball. The ball is clearly skidding. It actually goes into 6 degrees backward rotation, and you can see that it lifts 79 thousandths of an inch. It lifts in that, somewhere right in that area. So that lift is required to get the ball out of the depression that it's sitting in so that it gets up on top of the grass and you get consistent skid and roll. In this case, we're getting 14% skid, 86% roll. Makes it very consistent. If we have too big a loft, we loft the ball into the air and it bounces and it messes up our skid and roll, and therefore we get poor distance control. If we have too little loft, we drive it through the grass and it bounces and we get poor distance control. So here's a cautionary thing for you. I use a little loft fitting board here, but you can use anything vertical just to check out if you're changing the loft on your putter. So let's assume we have a 4-degree lofted putter and you're going to set up and you actually want to strike the ball with the shaft vertical. If I have my hands ahead of the putt, I am de-lofting the putter and I'm going to cause the ball to bounce. If I have my hands behind and the putter head, I'm going to increase the loft and cause the ball to bounce. So again, loft is very critical to the distance control of the putt, and it's something we really want to make sure that it's correct because we all want to putt better, and this will truly help you. There are 5 basic putter fitting variables, all very important, and each one of those variables has something to do with the distance or directional control of the putt. We're going to talk about lie angle. Lie angle is 100% directional control. And here's the proper lie angle as I'm holding this putter right here with the head horizontal to the ground. But you see a lot on television, or a lot of your buddies and people that you play with, where they'll have the toe up in the air because the lie is not correct. Well, if this toe is up in the air and the lie is off by 3 degrees, the toe is up in the air 3 degrees, you're going to end up pulling the ball a 1/4 degree left, and that's going to end up missing a 28-foot putt. And that assumes we have a 4-degree loft angle. Anytime we have loft on a putter and the lie is not correct, we're going to end up with either pulling the putt or pushing the putt, depending whether the toe is down or whether the toe is up in the air. So here's a demonstration that'll help you understand this a lot better. And I'm going to take this little device I made up right here, and what it is a putter head that's mounted on this thing, and I've got a shaft coming out it, perpendicular to the face, so this shaft is at 4 degrees of loft. So when I take this putter, and let's put the toe up 3 degrees, watch the end of the rod. The toe goes back to normal, up 3 degrees, I pull the ball. The toe is down, the heel is up, I push the ball. So toe up, heel up, toe up, heel up, and you see the end of the rod moving. Well, what happens is, anytime I have a loft angle on any golf club, and we're talking putters here, anytime I change the lie angle that was built into the putter, I end up changing the face plane, and I end up inducing a pull or a push to the ball. So let's go one step further to help understand it a little more. If I take this putter and I go all the way vertical with the toe, that means the shaft of the putter is laying on the green. And I roll a ball up to that and I hit it, guess what will happen? I will pull the ball, and you can see from this shaft right here, I will pull the ball 4 degrees left, the amount of the loft. I'll miss everything, obviously. But as I take this putter and I come back up, you'll watch the end of the rod, and it comes up to nice and straight again. So it's very critical that we always have our putter horizontal with the ground, because lie angle is 100% directional control of the putt, and it's absolutely critical that we check it out and make it right, because we will definitely putt better. There are 5 very important putter fitting variables, and each one of those variables controls the distance and/or direction of the putt. In this segment, we're going to talk about head weight, swing weight. They're basically synonymous because we really want to know what the head weight of the putter is through a given length. But our problem is that our club is assembled, and the only way we can tell what the head weight is and if it's the proper overall balance of the putter is to use the swing weight scale. So we'll refer to swing weight, which is the easiest way to check our putter, again through its given length and what head weight happens to be on it. Well, basically what we're looking for is somewhere between C8 and D6. If we're going to mess up, we don't want to go lighter than C8. We can go heavier than D6, but the desirable range is C8 to D6. Why do we want a certain head weight like that? Well, if you ever picked up putters and you've stroked them back and they don't stroke back real well, a lot of that can do with too light a putter head. Also, moment of inertia is a big factor in that, and that's for a discussion later on. But one of the things we want to be sure of is that, gee, if we're a woman, was our club cut down 3 inches about 4 years ago? Are we using an older putter that we haven't changed for years and years and years? Because putters, as they go back, were much longer and much lighter head weights and much lower swing weights. But today, everything's gone shorter, heavier head weights, higher swing weights. Why? Because research shows us that we get really excellent distance control with the proper weight on the head. But really, distance control is about 70% of getting the right head weight. Directional control is about 30%. So the proper weight on the head is really important. So if I have an older style putter and I put it in a swing weight scale, and here I've got one that is C0. Well, I want C8. That's 8 swing weights. That's 16 grams of weight that we would have to put on that golf club head to get it up to weight. So how do we increase the weight of a putter head? Easiest ways with lead tape. Lead tape comes in lots of different forms. Here I've got 2 little rolls right here. One's a high density lead tape, the other's a normal lead tape. Lead tape in this 1/2 inch wide roll basically takes about a 5-inch strip to be a swing weight. And here's basically the best way to put it on. I'm going to take these 2 5-inch strips that I have right here, and I'm going to put them down on the head, squeeze them down. I'll take the second strip, I put it down right behind the first. So I like putting the lead strips on the sole of the club, because you don't see them, they don't grab the grass, there's really no problem. If you need, and you don't, let's say you got a big hole in the bottom of your putter, it's one of these new modern things, well, you can go out and get automotive wheel weights, these stick-on guys. They're 1/4 ounce. A 1/4 ounce is about 7 grams, that's 3.5 swing weights. And remember I told you on the lead tape, a 1/2 inch, 5 inches long, 1 swing weight. So we just put 2 swing weights on this putter, so we took it up a little bit. Understand that you will definitely notice an improvement in your distance control and a little bit on direction control if you get the head weight on this putter correct and you use the swing weight scale to do it. There are 5 very important putter fitting variables, and each one of those variables controls the distance and/or direction of the putt. Today we're going to talk about putter head design. And putter head design basically is very important in both distance and directional control. There are a lot of design features in a head, and they're all pretty important, but there's one really important one that can really help us play better if we understand it. And that's the putter head's moment of inertia. Moment of inertia is defined as this putter head's resistance to rotation on off-center hits. In other words, if we strike the ball in the center of the face every time, which we're assuming is the center of gravity, we don't have a problem. But if we strike the ball out on the toe wants to kick open. We strike the ball in the heel kicks open. Well, why do we move the ball all over the face? Well, it's basically a couple factors. The higher a golfer's handicap and/or the lower their skill level, and also the longer the putt, the more you tend to move it all over the face. Those golfers obviously need higher moment of inertia putters. So let me show you a little example here. Number 1 is a touring pro's putter. If you look at a touring professional's putter and you can see this dot on the center of the face, this pro here actually hit it within a 1/4 inch circle, which is the average out on tour, regardless of the length of the putt. You can't do that. I can't do that. So we need to get some help sometimes if we're going to move it a little more all over the face. I have a very sophisticated putting robot here in the design studio. And I have a putter made up that's very special because it's adjustable in weight. Well, when I put this putter into my putting robot, and here you're looking at a heel and toe weighted very high, and we'll call this a 44 MOI configuration. When I strike a center shot with this putter, it goes right in the hole. This is a 24-foot putt. When I strike a toe shot or a heel shot, the ball will go down and be 3 or 4 inches from the hole, and generally sometimes it'll even fall in the hole, but it's usually just an easy tap in. However, when I take this putter in the robot and I take these 2 weights out and I put a similar weight in the center, So the putter still weighs the same 360 grams. I strike a center hit right in the middle of the hole. I now move the ball out and I strike a toe hit, and the ball will come up some 3 to 4 feet short and to the right. If I strike a heel shot, it comes up some 3 or 4 feet short and to the left. So obviously, which putt do you want? The 3 or 4 footer to knock in on your second putt, or high MOI putter that allows you to just tap in the putt that was off center. So here's what you want to do to check this out and find out what kind of putter you need. Go out and get some impact decals or put a piece of tape on the face of your putter. Hit some 30 and 40 foot putts like I did here. Then I took my Sharpie pen and I made dark dots on those spots so I know how far I hit it. Well, this told me that on these long putts right here, I'm going to need a higher MOI putter because I'm not in the Touring Pro range. I'm moving it all over the face. So moment of inertia, very important, gives us a basic understanding. Do the test on your putter head, and if you need to, go out and get a higher moment of inertia putter or try one, because it'll definitely help you score lower. I designed this dynamic putter fitting center to make sure that we cover all 5 of the proper fitting variables on putters. We go through the proper length, the lie, the loft, the head weight and swing weight, and the proper head design. Well, each of these are going to be covered in detail in individual segments. But right here, there's some things about putters that people just don't realize or think about on a day-to-day basis in using them in their game. So let's talk about a few of them so that we can check other things than proper fitting variables. First off, there are a number of different grips available on a putter. You don't have to be stuck with the grip that comes on a putter that you bought off a rack or whatever, or a grip you've had for years. You can put different grips on it have totally different feels, and you may even putt better. There are basically 2 types of putter grips to discuss. One of them is a paddle putter grip, and over here I've got a couple pistol putter grips. Let me show you the difference. First off, the paddle putter grips come in multiple sizes. And a paddle putter grip basically has a flat front, and they can be large or small. Some of them can be the same width all the way down to the bottom. Some of them can taper down to the bottom, as this Golf Pride grip does. And then there's some real large oversized ones like both Golf Pride and Lamp can make. So you have size variations of the paddle putter grip. Well, the big difference in a paddle putter grip to a pistol grip is in the back of the putter. In the back of the grip, as you see here, there's no kick out in the back. But when I go ahead and pick up the 2 pistol grips that I have and I hold them up, now you see that there's this kick out in the back of the grip. It comes up and goes out. It's like just like holding a pistol in your hand, so to speak, that has this big kind of a lump that comes back, and it feels very comfortable for some golfers. So it's something to try, and be sure to pick up different grips that are available for you, and also take a look at each one, feel what they feel like, go through the rack of putters in stores, golf shops, wherever you are, and feel them and see what you like in a putter grip, because it can possibly make you feel more comfortable. Okay, here's another key thing. When we look at a putter, we need to check it out every once in a while and find out what's going on. It's kind of nice to set it up like this and sight down the shaft and make sure, forget the bent part at the bottom, make sure you don't have a bow in the shaft. You haven't bent it in some way. You know, there's the occasion when you'd miss the short putt and you give it the old boomeroo like that. Then there's the whirly gig every once in a while. Well, it's nice to know that we did or did not bend it. So give it a little sight in multiple directions and make sure that it's straight. The other thing we want to do is grasp the head and grasp the grip from time to time and try to twist it in the head. Now, we don't have to bear down and try to kill it, but we need to try to twist it because many putter shafts are loose in the head. That's not a good situation. And here's another thing to do now. When you take your putter, you need to make sure that that grip is installed straight. Many of the putter grips are installed because they put on $1 million an hour in some of these plants where they manufacture them. Some of them are cocked a little to the right or cocked a little to the left. So simply take your putter and find a nice straight edge on the floor or wherever you can and set it down and hold it up and look straight at the face and make sure the face is perpendicular to that line on the floor, and sight down the grip. Just look right down the grip and make sure that grip is perpendicular or square to the face of that club. It's an easy little check to do, and you don't want to find out that your grip's twisted one way or the other. There's another thing to check. If you're playing with a putter that has a double bend shaft in it, many of these putters are suspect to not having the shaft installed correctly. A double bend shaft actually controls the lie of the club when it's put in, and also controls the assembled loft of the putter when it's installed. So the installation is very critical to be right on. So when you go into a place and you're looking at different putters, here's something to check for. I'm going to take, and I have 3 identical putters right here that are double bend shaft. And I have 2 of them with the shaft installed not correct, and I have 1 of it correct. So I set this down right here, and I'm just going to use a little board. Notice that shaft is perfectly vertical, and that putter face is dead square on that board. That is the normal way that a putter shaft should be installed if it's a double bend shaft. Now we'll take the next one that's installed incorrectly. So now, when we set this down, and we hold the shaft dead vertical once again, we look down and we see the face is open. We have to actually close that up to get the putter face square because the shaft is installed incorrectly, and it creates an open face. Now we take this next one and we set it down and we hold the shaft dead vertical, and you notice that the face is closed with the shaft vertical. So this putter here, when you open the face up to hit the ball, you're increasing the loft. That's not a good sign. On the one where we had the face open, and when you turn it in to hit the ball square, you're decreasing the loft. Well, generally these putters have 4 degrees of loft built into them, or somewhere right around there. So when it's open and you decrease it, you may now only have 2 degrees of lofted impact. When it's closed and you open it up, now you may have 6 degrees of lofted impact. That's too much. We get the ball bouncing. So these are critical things to check out in your putter. Let's say that you want to go ahead and add a little weight to your putter because it feels light to you. Well, here's another good little tip. You generally want to put the lead on the bottom of the sole, and here I've got a couple pieces of lead tape. Lead tape comes in normal kind of weight, and it also comes in a denser, heavier weight. Doesn't matter which one you use. Some people prefer different ones. Well, I like to put the lead tape on the bottom of the putter if I'm going to put it on, increase the swing weight. So there I put a strip on the bottom, and I'm going to take another strip and I put it on the bottom right next to it, and now I just put 9 inches of lead tape on this putter. Every 5 inches is a swing weight, so I put almost, not quite, 2 additional swing weights into this putter. You never see it when you putt. It's down there completely. It doesn't drag on the ground, doesn't cause any problems. So the best way for me is to put the lead tape on the sole. If you got a putter with a hole through the bottom or something, you can't do it, then put it somewhere else. So neat little tricks. And it's very important to go through once in a while, or even for the first time, check all these things out on your putter. We know the 5 fitting variables are extremely important to understand, but we also know there are a lot of other things that can affect how well we putt. A great way to improve your putting and better understand what's going on is to fully understand face angle and path of the putter. Now when we talk face angle and path, this also applies to woods and irons, but we're going to demonstrate it here using a putter because it's a really neat way to fully understand how it works. So I'm going to take this putter right here and I'm going to set it down. So I have 3 types of face angles I can possibly have. I can have an open face angle, a square face angle, or a closed face angle. Now regarding path, I have 3 more paths that I can have. So on my path of the putter, I can have a square path, I can have an inside to outside path, or I can have an outside to inside path. So I have 3 face angles and 3 paths. That should tell you that there are basically only, when I put the 2 of them together, 3 conditions that can possibly happen at impact. The face of the putter is either closed to the path, square to the path, or open to the path. Now, to make it a little more complicated, obviously you think, hey, if I get my face angle square to the path, I knock every putt in. Wrong. Your face angle can be pointed 1 degree or 2 degrees right of the hole on a straight putt, and your path can be coming through inside out, same 1 or 2 degrees. Therefore, the path and the face angle are dead square and the ball's going to miss to the right. So that didn't help, did it? We can do that to the left, and if we get it lined up right, it goes right in the hole. So those 3 conditions on face angle and path. So very important to understand that concept. Now, when the face angle, which is 85% in determining the initial directional control of a putt, and path is only 15%, so that makes face angle 8.5 times more important than the path, but they're both important. So now when we hit a putt, let's assume that our face angle is closed to the path. That means we're going to put a counterclockwise hooking side spin on the ball. That's not good. If our face angle is open to the path and we hit the ball, then we're going to put a clockwise slicing side spin on the ball. That's not good. So here's one of the things I like to do to let me know if my path and face angle is perfectly the square on my putter. So I take a golf ball, and every golf ball I play with has these markings on it right here. And the mark you see is a dot with a line on either side. I like the line because it does a couple different things for me. Number one, it helps me concentrate more on the putt because I'm using it as a lineup aid. Doesn't slow down the game at all, actually speeds it up because you know exactly what you're going to do. So I take this line and I get down on the green and I set my ball down and I line it up exactly to my break. If it's straight at the hole, I line the line up straight to the hole. It's going to break right to left, I aim it over to the right to the break. You always put that line to the break, and when you strike it, it will go end over end if your face path and face angle are dead square. And conversely, if you aim it the other way and have a left to right break, it'll do the same thing. It'll go end over end and it won't wobble. When it wobbles as it's going down on a putt, that means that the face angle to path was either opened or closed. You've wobbled it. So you need to work on face angle to path. But the lineup mark is great. And here we'll cut away to a couple different lineup marks. You can have a lineup mark that's a single line with a dot. You can do it the way I do it, a double line with a dot. You can just put the dot on if you don't like the lineup line, but I highly recommend using it. And notice also that we can take and put these lines on by using a little plastic cup or some device with a Sharpie and then put a perfect line on the ball. So I really like the lineup line. It can really help you concentrate on your putts. And furthermore, really understanding face angle and path, and in particular the importance of face angle on a putter, will really help you putt better. Just to kind of set the record straight, we need to talk about plumb bobbing for just a minute. We've all seen the guys out on tour, probably a good number of you guys all do it. You stand up and you hold the putter and you do this and you do looking at something. Well, there's a couple things wrong with plumb bobbing. Number one, most of the people that plumb bob, I'm making the assumption that they think when they hold the putter up, the shaft is hanging perfectly vertical so that they could look in some angle on the green and read something into it. Well, most of the people I see holding up the plumb bob don't even have it close to vertical to the green. And the other thing is, everybody I've asked, what are you looking for when you plumb bob? Well, I've never gotten the right answer yet that makes any sense to me. So let's take a look at this. Here's a putter. You've heard me say before that the center of gravity of the head, whether it's a driver, an iron, a wedge, or a putter, is not in line with the axis of the shaft. It's either back behind it, it's forward of it, it's somewhere. So, if I take the putter in this position right here and I hang this into the perfect plumb bob, because the CG's here, this shaft is actually, and I'm going to accentuate this, tilted in this direction by some, on this putter, 2 degrees. Now, if I turn the head the other way and I plumb bob, so the head's going that way, now I'll accentuate this, the head is some 2 degrees this way. Okay, now let's say I'm going to point the head straight at where I'm putting. So I put the head straight out, and I look down, and it's really off, and you can probably see this. It's tilted in that way by almost 5 degrees. So if I turn it the other way, now the shaft is tilted that way by the same 5 degrees. So, I mean, I can check this out. All I got to do is put a magnetic protractor on this thing and read it in whatever configurations it's in. And a good one I'll show you in a second is using a door jamb to line it up with to see where it is. Now, there is a place where I can get this shaft to hang exactly vertical. And that is I use a jam like this. A door jam is perfect. And I hold the putter up and I sight it into the door jam, because we're assuming our door jam is vertical. And I rotate the putter until this shaft is dead perfect with the door jam. And it so happens that for me plumb bobbing, this head in this exact position allows this shaft to hang perfectly vertical. So if you plumb bob, do you know on your putter where it's perfectly vertical? And if you do know, would you tell me what you're looking at when you get down and try to figure things out? So take the bulk of all people. We're out there holding a crooked shaft, we're looking at a crooked green, and we're trying to deduct the two differences and figure out which way to make the putt break. A little more complicated than I want to do it, but hey, if it's your thing, go for it. Let's talk about the set makeup of wedges. Let's talk about the length of wedges in your set and the swing weights of the wedges in your set. This is pretty interesting, and it's a way for you to go about and do a little checking to see how your wedges actually fit into your set. And also maybe do a little bit of additional thinking on the set makeup of your wedges. Most iron sets come with a pitching wedge. And definitely we want a pitching wedge in our set. The other wedge that we definitely have to have in our set is a sand club. Now there are three other kinds of wedges besides pitching and sand, and that's the gap wedge, which fills in between the pitching wedge and the sand wedge. Then there's the lob 60-degree wedge, and then there's the ultra lob wedge that goes up to the 63, 64-degree range. Well, I'm going to tell you right now, there are very, very few people that ever need to go to a 62, 3, or 4-degree ultra lob wedge, and I would kind of forget that club. If you do own one, count the number of times you hit it good and the number of times you hit it bad, and I'll guarantee you after you count it and you mark it all up and you take a score, you're going to chunk it out of your set anyway. So what I want to do here is, this is kind of a neat little talk, and here's something you can do. Run out to your bag of clubs and get your clubs and set them up on a table. Now you need a nice straight edge on the table. You're going to lay out your irons, and I have 4-through pitching wedge right here between my fingers. So I'm going to lay my irons out, and on the other end of the table, as you can see, I have each of the ferrules put up against the nice straight edge of the table so that I can look at the exact incremental length in my irons from the 4-iron, in this case, down to the pitching wedge. So you can see that I've got a 1/2 inch from the 4 to the 5, a 1/2 inch, a 1/2 inch, a 1/2 inch, a 1/2 inch right down to the pitch. So neat way to kind of check your irons out. Now I want you to also lay out your wedges. And when you put your wedges down on the table, we want to see where they're at. I'll bet in some cases you got a wedge that's a sand or a gap or a lob that's longer than your pitch, possibly. Run into that a lot. Or they're all the same length as your pitch. Well, that's not the ideal situation. What you really want to do is get your wedges set up so that they're basically in kind of an incremental order, sort of, to the clubs in your set. We're looking for consistency in length, consistency of feel, consistency of distance. We don't want wedges, and what do? We go out and we just pick up a wedge here, we pick up a wedge there, and we pick up a wedge here. So we don't exactly know where they're at, and we probably never check them. Some of the touring players I get in here don't check them, and I find this out, and they're going, oh man, that sand club always felt too long to me. Can we cut it down a 1/2 inch? Can we? Yes, we can. We'll get it all fixed up. So here's the deal. I've got a gap wedge here, and in an ideal situation, I'd like my gap wedge a 1/2 inch shorter than my pitching wedge. Got a sand wedge here. I really prefer to see the sand wedge a 1/2 inch shorter than the gap wedge. Then I've got a lob wedge here, a 60-degree. Well, in the case right here, I've got the lob wedge and the sand wedge the same length. I don't want to start getting too short on my wedges, and if I have a gap wedge, I'm going to make the lob wedge and the sand wedge the same length. Now, there is a situation where you can get rid of the gap wedge, and that's entirely up to you. I like to be able to put in another hybrid or some other club that may help me better, but you need to understand what's happening when you get rid of the gap wedge, and then how do I solve that problem? Well, when I take the gap wedge out, first off, here's what I want to do on length. I want to take the length of my sand club and increase the length a 1/2 inch from what I just showed you to make it a 1/2 inch shorter than my pitching wedge. I'm going to leave my lob 60-degree wedge the same length, which is a 1/2 inch shorter than the sand wedge. So I go pitching wedge, sand wedge, lob wedge, all a 1/2 inch shorter in increments right there. Now, when I take the gap wedge out, and here's what the manufacturers have done over the years, it's the stupidest thing. We have taken and made Loft so strong on our irons that we now end up with a pitching wedge, say, of 47, 48 degrees. We've got a sand wedge of 56, so we've got 8 degrees between those two. That's a lot, and that's where the gap wedge came in. And if you really need a gap wedge, go for it. But I don't use a gap wedge, and a lot of touring players don't use gap wedges, and a lot of good players don't use gap wedges, because I want another club, as I said before, that can help me more. So when I take the gap wedge out, what in the world do I do? Well, I have a pitching wedge, and I can take, and this is a pretty easy shot to learn, is you take a pitching wedge and you hit it 7/8 to 3/4, and that makes up for the gap wedge. And then you hit your pitching wedge full. So you've got kind of 3 shots with a pitching wedge, then the gap wedge can come out. And I told you before, you don't want the 63 or 64 big lofted thing. There are 2 wedges you definitely have to have in your bag: pitch and sand. The 60-degree wedge can help out in a lot of situations, but what you need to do is fully understand, do I hit the 60 consistently enough? Is it something that really helps me in my game? If it does, leave it in. So in looking at the set makeup of your wedges, use that kind of as a criteria. Now we go back and we do the other 2 things, or the other thing rather is swing weight. We've talked about the length, we've talked about the set makeup of wedges in general. Swing weight wise, the pitching wedge that comes with your set should be 2 or 3 swing weights heavier than whatever your iron swing weight at. If your iron swing weight at, let's say, D2, your pitching wedge should be D3, 4, or 5. Your sand wedge should always be basically 4 to 6 swing weights heavier than the irons in the set, so that would make the sand wedge anywhere from D6, D8, something like that. I also like to see the 60-degree wedge basically in that same similar range as the sand club, although it could be lighter if you have a personal preference. The gap wedge should be the same as the pitching wedge, D3, 4, and 5, if your iron set's a D2. So you want your wedges heavier, obviously. They have a certain function to do. You're not out to get a pitching wedge and hit it 971 yards because your buddy hits it that far. The idea of the wedges, they're scoring clubs, they're accuracy clubs, and we want to use them as such, and the heavier head weights and the higher swing weights help us do that. So take a good look at your wedges, get them all laid out on a table like this, find out where you stand, because one of the fun things when you want to get into doing some things on clubs is to either cut down your wedges a little bit, re-grip them, add a little lead tape to them, get them to where you want them and they feel the best, and I guarantee you it'll help you play better. To hit this golf ball solidly, we need to know a couple things about irons. We're going to talk about irons here and their playability factors. Not all irons are created the same. Some are easier to hit and some are harder to hit. So let's first see what it takes to hit a ball solid. I have a golf ball right here, and in this golf ball there's a center of gravity or a balance point, and it's right in the middle of the golf ball. Now, I have an iron head right here, and I pre-marked the face. And I have a dot on it which tells me where the center of gravity is located in this iron head. Well, to hit this ball solidly and get that perfect, wonderful feel that we're all looking for, I want to swing down with this iron, and when it contacts that ball, I want the center of gravity horizontally to line up with the golf ball center of gravity, and I want the center of gravity vertically to be below the golf ball center of gravity when I strike it. The lower I get the center of gravity of the iron below the center of gravity of the ball, the more solid the hit. Now it stands to reason certain golfers are sweeper swingers, where they come in with the club head horizontal to the ground. Well, you need a lower center of gravity to hit the ball solid if you're a sweeper. Then there are people that hit down and through it. They can play with a higher center of gravity if they want to, and they can drive the center of gravity of that club head below the center of gravity of the ball. So, the center of gravities are a mass property, and they're also a dimensional property of the iron because they're located in some certain location. So let's do this for a second. We're going to have to talk about a few different things to fully understand playability factor in irons, but we now know what creates a solid hit. How do we go about getting that? And I've been in this golf business for 40 years, and the last 30 years owning my own business, done hundreds of designs, and also I designed for 11 other different major companies. So I learned a lot. Thousands of hours of testing on machines, player testing, tour testing, and being out and letting tour players hit everything. You need all these types of tests, and also lab tests in the golf club design studio that I'm sitting in right now. Let's take a look at a club right now and see how we go about this so you can understand a little more about mass and dimensional properties of an iron head and what makes one play differently from another. On the screen here, I'm in a wonderful CAD program that I use, CAD-CAM. CAD is computer-aided design, CAM's computer-aided machining, manufacturing, whatever you want to call it. Here's an iron head that I did, and we like to design using 3 different planes. We designed the face of the club, the hosel of the club, and the back of the club separately so we can move them around and do things to get all this mass distributed correctly, if you will, within the iron head so that we have high playability or whatever playability we're looking for. You're building a classic muscle back iron, you can't get playability as high as the moon, but if you're building a cavity back, longer blades, you can start getting really high playabilities, wider sole widths. So here's an iron design, designed in CAD. Well, I want to know how this thing's going to play, so I need to build one. So we're going to make one right here, and we're going to build it out of a 16-pound block of mild steel. So here's my design of the face. So right now I go into my verification program, and I go up and I click cut, and now you're seeing it cut on the screen. And what I'm doing is doing the first program, which is the face of the club. And I'm now going to put the radius in that goes into the hosel. I'm putting the face lines in. The next program is to go ahead and put the hosel in. The next program after that's to put the back in. So as you can see from this block of steel, there are a face program and a hosel program already cut into it that are our start. Next we'll do a back program, but we'll do that later on, and that's not part of this discussion. But from this discussion, what it means is we need to know where all the mass is distributed in that club and our moment of inertia of the club, our center of gravity locations. So let's go on to the next step. This is the prototype head that we just designed in CAD on the computer. We machined it in that Verify program to check it out, and we also machined it out of a 16-pound block of steel. So our prototype's sitting here, and it's on a center of gravity tester. I want to find out the center of gravity location so I can actually calculate it and find out where it's really located in this one little pinpoint somewhere within or outside the head itself. So I use this center of gravity tester. I've got a Sharpie pen that goes up through a hollow point. You can see the iron is balancing on the tester. So I use my Sharpie and I go up and I make a mark in the face. Now I have the center of gravity location from toe to heel, or the horizontal location, and I also have the basic vertical dimension of center of gravity. So I can put this in my digital height gauge and I can run the needle in and it'll tell me this exact center of gravity height where it balanced on the face. My next step is I can balance it on the sole of the club because I need some more measurements. So I use the same center of gravity tester, balance it on the sole, and now I end up with a dot and I end up with my rearward center of gravity location. So now it's a matter of taking some trigonometry and going ahead and calculating that exact precise point where the center of gravity is located, which is a very key point in playability factor. Another mass quality of the golf club that's very important in multi-playability factor is moment of inertia. We've seen it in all the ads in magazines, manufacturers tout it all over the place. Well, moment of inertia is very important in putters, irons, woods, every golf club in your bag. So here's basically what it is. Take a look at this machine. It's an aerospace machine. It measures moment of inertia. The iron is up on top and it's rotating. What that machine is measuring is that club's resistance to going in the opposite direction, or how high the moment of inertia is. So what that means to you is that on off-center hits, when you're not hitting it right on the middle of the face where the center of gravity is, you're going to get a more solid and a more consistent shot more of the time. In other words, instead of a toe shot going into the bunker, you might possibly get it over the bunker and onto the green. That's a high moment of inertia. A low moment of inertia just makes it more unsolid more of the time unless you're hitting it right on the center. Watch this demonstration and this will help, and you can do this and actually feel high and low moment of inertia. Here's 2 wedges. I'm going to put the heads in to the center of the apparatus that I made up here, and I'm going to spin it. And it spins quite easy. Very low moment of inertia. Easy to do. Now I'm going to take and reverse the heads, and I'm going to put them to the outside. And now I'm going to grab on and I'm going to spin it, and wow, is this tough to do. It almost wants to break my wrist. This is a very high moment of inertia. The whole mass doesn't want to go in the opposite direction very well, so that'd be great in our iron set. So what I basically did is take these mass and dimensional properties of the club head and came up with multi-playability factor. And what it tells you is this: the farther out I get the center of gravity horizontally from the center line of the shaft or hosel, the easier the iron is to hit. The lower the center of gravity is in the head, the easier it is to hit. And that's basically multi-playability factor. Now, keep in mind, and there are 6 categories, of playability factor. Player classic, classic, conventional, game improvement, super game improvement, and ultra game improvement. So those categories will help you, and all these heads behind me have been put into those categories. Some of these go back to the 50s, but it's mostly all the modern era heads. And playability factor basically will tell you the winners and losers in the marketplace. It's very consistent on that. So we keep it up to date, and people can look up and see what the playability factor on certain heads are. Now, here's what playability factor won't do for you. Playability factor, as I said, is the mass and dimensional properties of the head. It predicts and tells you exactly how solid this thing will be on off-center hits or playing and hitting balls all the time as you come into impact with the club head. It doesn't have anything to do with the shaft. You need to go in and get a proper fit from an individual. You need to get the lie set right. You got to get the right shaft for you, the right length, the right grip size. All these are very important. So if you take multi-playability factor and then you take the proper fit from someone that really knows what they're doing, then you get this so-called dynamic playability, and you can go out and play better. It's a great way to figure out which head design is going to do the best for you. The number of women taking up golf is one of the fastest growing segments in the golf market. The problem is there are a lot of women that leave golf. They don't all stay. And one of the problems is when you interview everybody is you find out basically that it's too hard a game, or it takes too much time. We all run into that. But basically too hard a game is the main reason. And a lot of that stems from the fact that women don't have the right equipment. Let me just throw this out in the beginning. If you're a woman golfer and you got equipment from your husband, your grandfather, your father-in-law, your boyfriend, or your brother, or wherever it came from, if it came from a man and he told you, look, you take up the game, and if you play and you really like the game after a year, then I'll get you your own equipment. Well, if you're playing those clubs, you have a huge problem, because men's golf clubs are not even close to what a woman needs to hit the ball. So back in the early 90s, to mid-90s, I did some big studies on women to figure out what really helped them and to provide better golf clubs for women golfers. And here's what came out of that. Number one, women don't take divots. Women basically swing with a sweeping swing through the ball instead of hitting down and through it sharply. Some women hit a little bit down and through it, but the point is most women don't take divots. You think about the average woman's about a 31, 32, 33 handicap. The average male handicap's about 18. And women have a totally different type of game than men do. So when women look at golf equipment, and let's start off with irons, what do they need to do? If they're not going to hit down and through and take big divots and be sweepers of the ball, then they need specialized equipment. And it has to be totally different. You can't use the men's head and just put a different shaft in it and cut it down shorter and put a small grip on it and sell it to a woman. You need a special designed head. And here's what happens. Basically, women need golf club designs, and in irons we'll start off, as I said, that are the highest multi-playability factor. You need to start in ultra game improvement. Why? Because if you sweep the ball, you need the lowest center of gravity you can get in an iron so that it's always below that of the ball. You need center of gravities that are farther out from the hosel in the iron head so the club head's more stable. You need wider sole designs like this one versus the other one I'm holding, and you need more bounce on those wider sole designs, meaning that the trailing edge of the iron is lower than the leading edge of the iron, so it hits first coming into impact. So a woman golfer with a sweeping swing can come into impact and hit the ball, or hit a quarter, a half, 3/4, or 1 inch behind the ball, and the iron will go right into the ball. The low CG will help it get into the air much easier than anything else, and the bounce on the sole will keep it from digging. So you lose this fear of hitting this fat shot, if you will, when all you have to worry about is hitting it too thin. Just hit right down behind the ball and don't worry about the club head trying to dig its way to China. It won't happen if it's properly designed. So high playability irons, you don't want skinny soles, and you certainly don't want short blade lengths like the club I'm holding in my right hand. There's a lady's blade length. Now look at the length of that. And recognize that it's kind of been a fallacy. Women's golf club heads are heavier than men's simply because they're shorter, which brings up the fact of ladies' club length. Women basically need to be under, maximum of rather, 37¼ inches on a 5-iron length. I prefer to see it 37 or 36¾ A men's length is 37½ to 38 inches on a 5-iron. So, big difference in length on ladies' 5-irons to men's. The other thing is men's 5-irons are generally 25, 26, or 27 degrees of loft. Ladies' 5-irons need to be 29 and 30 degrees of loft. So they're shorter, they've got more loft, and they're heavier because they are shorter. And they're in ultra-high game improvement, and that makes a woman play better. Two other factors to quickly talk about, and one is be sure to get fit for the proper grip size. And here's some cut-off shafts with 2 ladies' grips on it. And I have an oversized ladies and a standard ladies. Most women are going to fit into the real lady standard size. Manufacturers all have their own lady standard size, and as far as I'm concerned, they're all too big. Some of them are a 64th to a 32nd oversized ladies. So be sure to go in and check your fit for proper grip size. Makes a huge difference in playability. The other factor in ladies' clubs is the shaft. One of the biggest selling things I ever did was design a double L-flex or a soft ladies flex shaft. And I did that because in testing I found out that women hit the soft L-flex, almost all of them, unless you're an LPGA future star, that's a whole different ballgame. But women hit these much better. Why? The shaft does a lot of bending coming into impact. It increases the loft of your clubs, it closes the face, it flattens the line, it does a lot of things. Well, women need to get the shaft to actually bend so they can utilize it like the stronger men do or the faster swinging men. So you want a softer flex shaft. And on this shaft right here, it also has most of its bending down in the tip area versus up in here where you don't want it to bend. You want it down in here. And the fact that it's a higher torque and it may hit the ball a little more right or left is totally irrelevant because this shaft into a high game improvement head with the wider sole and the bounce and everything is going to give you more solid hits more of the time. You can hit it all over the face right to left and still have solid shots. So all of these features are very important to women's golf. Now talk about the driver for 2 minutes. The driver really shouldn't be over 43 inches long unless you can handle it. If you can, go for it. But 43 is generally the maximum. Women are basically, you want to get into these big new drivers. You don't want that old driver. You want as much game improvement as we're building into all the men's clubs. So you want a 435 to 465 cc driver so that you can get the benefit of all the action that big head can do on directional control and ease of hit. So you're also going to want to be 43 inches and you're going to also probably be at least 12½ degrees of loft. Very important. Don't you buy anything unless you go into a store, a pro shop, wherever you're going, and you hit it. And you've got to go and check your driver out in a launch monitor. So if they got a launch monitor, you need it. Get in that launch monitor, it'll tell you if you need 13 or 14 degrees loft, or maybe you need a 12½ or a 12. And ladies' clubs are available in multiple lofts. My guess is you're going to need a minimum of 12½ degrees of loft. So go out and hit the clubs, as I said, knowing that club head designs have come a long way, but it's the total club that I'm worried about putting into your hands. You want the right shaft flex, you want the right grip size, and you want that head to perform for you. And ladies' clubs, again, are a very important segment of this market, but a lot of manufacturers don't take it super seriously, but a lot of them also do. Understanding the importance of lie angle in your irons can help you in a couple different ways. First, it'll help you, once you understand it, that you may want to go out and get the lie angle set on your irons correctly if you haven't already. Secondly, it's going to help you understand what happens when the ball is either below your feet or above your feet out on a golf course when you can't have the proper lie angle. Proper lie angle is set basically to be on flat ground. So here's a little explanation of what happens so that we can learn what lie angle actually does, because it's a directional control factor in striking the ball. I'm going to take and set up right here like this. This iron happens to fit me perfectly in lie, so watch this demonstration as we go through and you'll see how we get to the final fit. I get set up at address, and there's my address position. And you can now look down at the head of the iron on the floor, and you'll see that the toe is up in the air and the heel is down low. So Obviously, right now, it doesn't seem that this iron fits me because it's not set properly in the right lie position. We'll go over that in a second. Here's another thing that happens. From setup right here to coming through at impact, my hand position changes. I'm set up down here, and at impact I'm up here. There's a 2 to 4 degree raising of the hands, if you will, that's created by the centrifugal force of the swing. So from address down here, you come through impact up here, so that flattens the head down somewhat. So now when we take a look, and let me come up to the impact position, you'll see that the toe is down more than it was before, but it's not all the way down to the ground. It's still a little bit toe up, but not as much as our original address position. So how does it get the rest of the way down to get into the proper position? Well, coming into impact, because the center of gravity of this head is not in line with the axis of the shaft, we actually get a bowing down of the shaft, as you see right here. And that bowing will bow down differently on every length of iron, but on this particular 5 iron here, I'll probably get a degree or a degree and a half of flattening of the lie because of the bowing down of the shaft. So now when I come through impact, the position of the head will be in the proper lie position as it sits right now, and it's basically parallel to the ground. So my lie is correct because it's gone through all those dynamic iterations of starting off with the toe up, then the hand position changing, and the lie flattening because of the bending of the shaft. So we need a couple more little demonstrations here and things to go a little further so that you really understand what's taking place with the plane of that face when the lie angle is correct or incorrect. To really understand how directional control is affected on irons if the lie angle is not correct is easy to do with a little gadget like this that I made up. And what this does is I have a pitching wedge mounted on it of 48 degrees loft. And you'll notice I've glued a bar on it that comes straight out of the face plane. And the leading edge of this is mounted such that it's pointed directly at the target in all cases through any given lie angle. Well, here we have the lie angle of the club right here. And you can see we have a loft angle. Well, if we have two angles, a lie angle and a loft angle, anytime we introduce another angle, which is flattening of the lie, that other angle we just introduced is a tilting of the face plane. So you can see that now we're going to pull the ball to the left. But I go back to the correct lie, it hits it straight. I go to an incorrect lie with the toe down, it hits it to the right. Incorrect lie with the toe up, and it hits it to the left. The greater the loft you have on your iron, the greater the pulling effect of the shot. In other words, in an entire set of irons, if they were all, say, 2 upright by 2 degrees on the toe, being up, then you're going to pull the 9 iron far greater to the left than you will a 1 or a 2 iron, even though you hit them farther. So it's really important to get all your irons checked correctly for lie so that you don't have to worry about going through this effect here in directional control. Very important in the short clubs, but very important in all your clubs. Okay, that was a pretty neat demonstration, and that should have showed you how important the lie angle is when we tilt the face plane from an incorrect lie. How do we fit lie? Well, here's basically what we do. We take and we put a little piece of masking tape or black electrician's tape on the sole of an iron. I like to use masking tape, it doesn't matter. I put a little line to show the middle of the face. That helps me in determining where this mark's going to come through, and the mark's going to occur from hitting. So what I've got is a little lie angle fit board down here that's a piece of plastic, and you actually have to be warmed up, hit full shots. You must have the ball, you can hit them into a net, but the ball must be hit and it must be a legitimate ball. Can't hit a wiffle ball or anything like that. So I would just set up normally. I've got my masking tape on the sole, and I would take a swing and bam, hit the ball, and then I would just look at my tape. Well, if my mark comes through in the heel area, that's going to mean that the toe is too upright and I need to flatten the lie. If my mark comes through in the toe area, it means that my lie is too flat for me and I have to make the lie more upright. So there's a way to fit lie and understand a lot more about lie, and the key thing here is to show you the tremendous importance of having the lie angle fit properly on your irons, because you don't want to have to worry about whether did I pull the ball or did I push the ball or was it the incorrect lie on my irons. The best way to look at a golf club regarding playability is to look at both the head and the shaft as two separate objects. So, in understanding this, let's discuss the head first. What does the head do? Think of the head as a freewheeling object coming into impact. The head acts on its own mass and dimensional properties. In other words, its moment of inertia. Where's the center of gravity located? The bulge, the roll. All the features of this head have something to do in the collision when the golf ball smashes into this face. So, the head is a freewheeling object and it's basically on its own. So then what in the world does the shaft do? Well, the shaft also has a lot of interesting properties. It has a certain flex, we all know, stiff, medium, extra stiff. It's got a certain torque to it. It has a certain bend point, and that's where it does its maximum bending. We've all heard terms like tip stiff, tip weak, butt weak, all the different things. There's a lot of characteristics to the shaft. So what does all this mean? What it means is this. The head's a freewheeling object, as I mentioned, so what in the world does the shaft do? The shaft's job is to bring this head into impact every single time the same. So this shaft takes your swing, your untimed lunge, whatever you have, and its job for you is to get that head into the same impact position every single time. So when the shaft does that, we end up with consistency on every given shot. Easy to say, tougher to find the right shaft and the right combination head. So here's what the shaft does. When this club head is coming into impact, and I wind up and I take that big driver swing, there's a lot of bending going on. And in the shaft what happens is this. The shaft, because the head is going faster than at any other point along the shaft, and you release your wrist coming into impact, the head actually passes the shaft, and the shaft is bent into this configuration. Well, in this configuration, when the shaft's bent this way, it actually closes the face angle of the driver. It increases the loft of the driver. So the shaft has a dynamic influence on the head at impact. The other thing that happens is, coming into impact, because the center of gravity of this head is not in line with the center of gravity, or the axis of the shaft rather, then the club head bends down in this configuration, so the lie is flattened. So we have the face closing from shaft bending, the loft increasing, we have the lie flattening, and a fourth thing occurs, and that is that the club actually shortens by almost 1/4 of an inch in a driver because the shaft's bent in so many different directions. So it's a very interesting thing, and I think the absolute best way to analyze your equipment, particularly your driver, but it applies to everything, in looking at the shaft and what it does, and the head and what it does, and separating the two out so that you can find the best combination for you. One of the variables not to overlook is proper grip size. It can cause problems in your game. One of them is, and ask yourself, do I sometimes hit the ball right? Do I sometimes hit it straight? Do I sometimes hit it left? That can be grip size, generally too small a grip size for the individual. Or ask yourself, do I almost always just push the ball to the right and I have a heck of a time? That can be too large a grip size for the individual. Now, there are also other fitting variables that cause those same problems, but we want to take them one at a time, and let's start off with this grip size thing and learn a little bit more about it. The size problems and also how to go about fitting it. So let's start off and see what causes this problem. So I'm going to start off, and I've got a cucumber here. Great thing for a demo. If I take this cucumber and I pretend it's a grip and I'm going to hit the ball, and now I want to just rotate my wrists as fast as I can and check my wrist action, it's very difficult for me to do that because my fingers are spread out so large like this. However, if I take a carrot, skinny little carrot, and I put my hands on it and it's a really tiny grip, man, I can just turn my grip hands everywhere I want to turn my hands. I can rotate them. So the thing that happens is, when I have the cucumber, I get an inhibited wrist action. It doesn't allow my wrist to come through in the proper roll rate or whatever wrists do coming into impact, but it definitely will cause a right-handed golfer, if your grip is too large, to push the ball to the right. And that's basically inhibited wrist action. The too small a grip will tend to have you hit it all over because you've got this wrist action that just goes wherever it wants to go. It's uninhibited, if you will. So what do we do about that? We want to go out and get our grip size fit. We can actually check it ourselves, and if we go out to get it fit, many places will have cut off shafts with grips mounted on them like this, where it goes from men's undersize all the way through men's standard size and even has arthritic on it. Plus the lady size grips are in the background here. It's a great way to check grip size. So let me show you how you check grip size. Let's do it on the cutoff shaft first, and then we'll do it on a golf club so you can check your own. But if you're in a location that has all these grips cut off, this is a neat way to just, you pick them up and check it out yourself and see which one fits and feels the best to you. So what I do is I want to get into my normal hitting position. I want to be in my hands and everything, just like I'm going to really hit a ball. Tough to do when you got a sawed-off shaft like this. So I want to be able to be in that position, and I want to put my normal grip pressure on the grip. So what I do next is I drop my right hand off, and I come up and I take a look at these two fingers right here. If there's a gap in these two fingers to my palm, the grip is too large. If the two fingers are digging into my palm, then the grip is too small for me. If the fingers are barely touching or just slightly gapped, then the grip is the proper size for me under the left hand. If you're going to check your clubs right now, just take your club and go out and again get into the normal address position. Here's a little cautionary thing, and this is why we get in the normal address position. Don't overlook this point, it's very important. You get in the normal address position because people basically have two extremes. Most people are normal, but there's two extremes in setting up to the ball. Some people set up with their hands up very high like this, and they're in a much more upright position. Well, when you do that, the grip will feel bigger to you because your hand is on at a slant onto the grip. If, however, you hold it very low, very flat like this, and your hands are down low, your left hand is on in much more of a square position, so the grip will feel smaller to you. So very important, and that's why we pretend we're going to hit the ball, we get our normal grip pressure, and we come up and check grip size. So, you see the basics of understanding what improper and proper grip size can do for you. So, check it out, see where you're at, and go out and you will definitely play better if you're into the proper size grips. And also that they're not hard, worn out, or slick. If they've been on there for more than 2 years, you got a problem. When you're out practicing or playing around a golf, you have to ask yourself sometimes, when you don't hit the shot that you wanted to hit, is it me or is it my equipment? Interesting question. And one of the things I have sitting right here is a robot that I designed about 16, 17 years ago for doing putter head testing. Robot works phenomenal. There's actually 4 of them here in the design studio. On this particular robot right here, I've hit thousands and thousands and thousands of shots, done a lot of statistical analysis. Well, one of the things I found out in trying to get data on different types of putters and different specifications of putters is the fact that not all golf balls are created the same. And what I found out early on in the 90s when I tried to use wound balls and get statistical results, didn't work. Proved to me right then and there that I would never, ever, ever play a wound ball. Then the two-piece balls were coming out then. And the two-piece balls that I would get would now give me statistical significance where I could actually get some very good data, but I could never use a wound ball. But also I would find some of the two-piece or the new three-piece balls that really wouldn't work out well. So I started balancing all the golf balls before I first did putter testing. So when I balanced the golf balls and I ended up with balls that were perfectly balanced, I found out that my results in putting just got better and better and very statistically significant, and I could get repeatability with the tests, therefore proving out certain aspects of putters. So what we're going to do here today in this segment, we're going to take a golf ball, and I happen to have a ball right here that it's a 2 or 3 piece ball. It was improperly molded. Somehow the center's not in the right place. The center of gravity, therefore, is off inside the ball. And when the center of gravity is not exactly in the middle of a golf ball, as it rolls, and you have the heavy side to the right or the heavy side to the left, depending on where the center of gravity is off, or you have the center of gravity vertical in it, or wherever you're setting it down, you're going to get a different putt result. We stand right here and have a 24-foot putt. 24-foot putt to the hole, and what I'm going to do, and we're going to start off, and you'll notice that there's a black mark on this golf ball, and this is a pretty bad golf ball for having its center mismolded. And one thing to say is that most expensive top-grade balls are very good because they're x-rayed during manufacture and or checked some other way. A lot of the balls, though, don't go through the x-ray machine on the, say, lesser brands or cheaper brands, but some companies x-ray everything. So it's up to you to kind of find out if the ball is really good or not, and it only takes a second to check them. We're going to do that in a little bit. But first off, I'm going to show you what happens when the center is actually off. So again, I've got a dot on the ball. I'm going to set this dot down vertical. I can put it straight forward or straight back or straight down or straight vertical because I'm going to be in the right plane where I've got the heavy side of the ball in the plane so that this ball should putt normal. So heavy sides down. I'm going to start off and put this dot up. So I set it right in the middle of the putter face, and we come up here with our machine and we set it. Steady the head. We hit the putt, and it goes right into the middle of the hole. So what we're going to do is retrieve that ball, and next we're going to put the weight to that side, then we're going to put the weight to this side, and we'll see what the results are. Okay, I'm back. We're going to take the weight now. The dot again is the light side because it's up. This ball was floated, and the bottom's the heavy side. So we're now going to take the heavy side toward the camera, and we're going to set it down right on the middle of the face. Heavy side that direction. We're going to set our robot, steady the head, release the putter, and the ball misses on the right side of the cup. Okay, and now finally, I'm going to take the dot and aim it toward the camera. That's the light side, so the heavy side's going to be going this way. So we'll see what happens right now. So we'll set the ball down. Dot's at the camera, heavy side's toward the wall over here. We set our putter, we'll steady the head, we'll hit the shot. The ball is going down to the hole, 24-foot putt, misses on the left side of the hole. So that ball, with the weight up or anywhere in that plane, goes right in the middle of the hole. I turn the weight to that side and it misses to the right side. I turn the weight to this side and it misses to this side. The golf ball is very important, so let's next show you how to find out if the golf balls that you're playing are properly balanced. I learned early on in golf club testing, and particularly putter testing, that not all golf balls are the same, meaning that some golf balls are not balanced properly. And by balanced I mean this. Here's a good demonstration. If I take a pencil and I take it and I put it under the dimple on this ball and I balance this ball on the pencil and I draw a vertical line up through the middle of that ball, I now have a vertical line from the point of the pencil. Now I go over to another dimple and I balance the ball and I draw a vertical line. I go to another dimple and I balance the ball and I draw a vertical line. Let's say I do every dimple on the ball, but I don't have to. All of those vertical lines will intersect at a tiny little dot inside the middle of that golf ball, and that's going to be the golf ball's center of gravity or balance point. So center of gravity and balance point are basically synonymous for what we're talking about. Well, what happens is some golf balls, the centers will get off molded. And what happens when the center of gravity is to one side or another, slightly, now we're only talking thousandths of an inch, we end up with a heavy side to the ball and a lighter side to the ball. Well, depending on how we orientate that heavier light side, and let's say on a putt, we may be able to knock the putt directly into the hole, or with the same given stroke, we may end up missing it on the right or the left. So it works like this. If I take the heavy part of the ball and I set it down to putt it and it's on the ground, or I can put the heavy part up, or I can put the heavy part facing forward. As long as it's in that rolling plane that goes to the hole, then every time I putt the ball, if it's a perfect stroke, goes right in the middle of the cup. However, if I take the heavy side of the ball and I place it to the right, and I hit it with this precision robot that I have, the ball will miss the hole to the right, and I use a 24-foot putt to demonstrate this. Thousands of students have come through this studio and seen this demonstration, so nothing is being fudged at all on doing it. Again, if I take the heavy side of the ball and I place it to the left, and I strike it with the robot on a 24-foot putt, I miss the ball to the left of the hole. So we need to be able to find out, are the golf balls that we're playing, are they perfectly balanced, or is there one that's really off? Now, most top grade balls are X-rayed. And in this studio, I use 2 brands of balls. And this is not to say that any other brand has a problem. I just picked 2 to be consistent and stick with them. I picked top grade Callaway balls and top grade Titleist balls. And I balance every one, and to this date I have never ever found one of those balls out of balance. And those are the top grade balls from those manufacturers. Probably, I don't know about the Hogans and the Nikes and all that. I am not in the golf ball testing business. I actually found this all out because I'm in the golf club design business, and I needed consistency and good data. So therefore I had to find out things that, well, not all golf balls are created the same, and we don't want to play with something where we've got to go when we miss the putt, gee, was it me or was it my equipment? So let's go a little bit farther and do a little test here. There are 2 ways to I think there was 3 fingers. There are 2 ways to basically check the balance on a golf ball. And one of the ways is you can buy a little spin balancer that they have in stores, and you've seen them advertised. You just press the button and this thing spins up to some god-awful RPM, and you put a mark on the ball. Well, the spin balancer works from the standpoint that any ball that's out of balance, it'll put the mark in the right place. I don't like to use the spin balancer, even though it's very neat and clean and easy to use, simply because it doesn't tell me if the ball is absolutely perfectly balanced, which every ball has got to be just the minusculest out, and this will mark that ball there, which is meaningless to putting because you're not going to miss the putt. I want to know if the golf ball is really bad. And that's the ball we use in our demonstrations, and it's out pretty far. So I'm going to show you how to find out. A little messier setup, but still the easiest way to go. You can buy a kit. You can get a kit that comes with some salts in it, and the salts are mixed up with a adhesion eliminator, if you will, that helps the ball spin and float, and we can tell what happens. So what we do is we take this kit apart, and we find out we've got a little bag of salts. It takes a lot of salts, this whole bag, into a jar of water right here. Just warm up the water and stick them together, mix it up a little bit, and you've got your solution. Lasts for 2 or 3 years. You don't have to worry about it. You just need some paper towels around because salt water gets a little gooey. You also get a Sharpie pen in the kits. You can use the Sharpie, and I'll show you how that works here in a second. So let's actually do a ball balancing thing here and show you the 3 conditions that occur when I balance a golf ball. So when I balance a golf ball, we're going to start off with this demo ball that I had, which is my Callaway that I use in my tests. I'm going to put it in and I spin it. And I spin the ball and I get my Sharpie out and get it all set up, and if I want, I can take it, where the ball absolutely stops, I put a little mark on it by just punching down on the ball, just a little mark. Now I spin the ball again, and when I spin it again, the ball comes up to a different location. My mark's not on the top. And when I spin it again, the ball comes up to another location and my mark's not on the top. That ball is perfectly balanced. There's no reason to go any further with that ball. So let's take it out of the solution. And the next thing we're going to do is take a ball that's the next condition, and that's one that's slightly out that you definitely should mark when you're putting, and just put the dot up and then putt the ball, and you don't have to worry about it wanting to go right or left. So let's put this ball in, and we'll spin it, and it stops with the mark that I put on it pointing straight up. So I'm going to spin it again, and it comes up very slowly, but it comes up to the same spot every single time. So there it is. That ball is slightly out and then needs to be marked, but it's a good ball to play with. Just know that when you're putting, you want the mark up. Now here's the ball that we don't want to play with. And you'll find some of these, and particularly as you get down in price range and in different types of constructions of balls. So I'm going to put this one in, and I kind of spin it with my finger, not very fast, you just flip it over a little bit, and whoop, up it comes with the dot that I had pre-put on it. Now I would generally be, when I found it, I'd be putting my dot on and spinning it and then seeing how fast it comes up. Oops, right back up again. I spin it, right back up again. Reminds me of the Joe Palooka doll I had when I was a kid, which was one of those things with a big heavy base, and you punched it and it came right back up. The center of gravity was very low in it, and it forced it to just jump right back up. So this is the ball I don't want to putt with. So balancing golf balls is very important, and the touring professionals that I have come through here, and I do tell them the balls that I have never ever found one unbalanced, but I said, you know what, then maybe someday they'll have an unbalanced ball and maybe you could catch it. Because certainly you don't want to miss a putt simply because you didn't recognize that the golf ball you had did not have its center of gravity or balance point in the middle of the ball.